All right, we're going to start and go through our cumulative review number 4. So a reminder, these videos are to help you as you work to solve these problems. If your answers match the answer key provided, then you're probably in good shape, but you can also go through and hear the explanation of how we got to those answers by watching this video. So this first one, there's a couple different ways you can start this, as there are for a lot of these problems. Some students I saw in class isolated the square root, and then they squared both sides, and they ended up with like 36x squared minus 85x plus something, I think. But that gets pretty messy. I mean, you can do it, you'll get to the same answer. I think in this case, it's best to recognize that what you have here really is 6 square root of x squared minus 7 square root of x minus 3 is equal to 0, in which case we could do a u substitution where u is equal to the square root of x. And now this becomes 6u squared minus 7u minus 3 equals 0. Just works out a little bit nicer. So things that multiply to negative 18 and add to negative 7 are going to be negative 9u plus 2u. And then I still have my 6u squared and minus 3 is equal to 0. Now I can factor by grouping. It looks like I can take out a 3u here, and I'm going to be left with 2u minus 3. And then if I take out a 1 here, I'm also going to be left with 2u minus 3, which means factoring by grouping was successful. So I get a 3u plus 1 and a 2u minus 3 is equal to 0, which means that 3u plus 1 equals 0, 2u minus 3 is equal to 0, u is equal to negative a third, I said it, I didn't write it, and u is equal to positive 3/2. But this question said to solve for x, not for u. So we're going to go back and we're going to replace u with the original substitution that we made. And then to get rid of that square root, we're going to square both sides. So x equals 1/9 and x equals 9/4. Now, had you done this by isolating the square root and using the quadratic formula, you will get to the same two answers. They just might take you a little bit longer to get there. I think, like for instance, one of them comes out as 81 over 36, which really does simplify to 9/4. That just gets to be some really big numbers. All right, this next one. If I try to look at this to factor real quick with guess and check, kind of a struggle. So next thing I might try to factor with splitting the middle. So I multiply to 28 and add to negative 3. So you might jump to things with 7 and 4 and you would be correct, except you would need one of them to be positive, one of them to be negative, and unfortunately that is not the case. So this does not factor, and when a quadratic does not factor, the next thing you want to try is the quadratic formula. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So x equals 3 plus or minus the square root. Let's see, we get 9 minus 4 times 7, which is negative 103 over 8, and we can take out an I, but I don't believe that 103 is going to have any other perfect squares that come out of it, and 3 and 8 and this I do not simplify, so there are your two final answers. All right, next one we have a rational equation. So thinking about rational equations, you want to multiply through by the least common denominator. Least common denominator in this case is going to be our two current denominators multiplied together. So if I multiply this term into this first fraction, the x plus 1's cancel out. I am left with 4x plus 2 minus, if I multiply this into this term, the x plus 2's cancel. I'm left with 3x plus 1. And then when I multiply it on this side, I'm going to be left with x plus 1, x plus 2. So on the left side, we got 4x plus 8 minus 3x minus 3. This side I'm going to do some distributing, x squared plus 3x plus 2. So I've got a quadratic, because this x squared term going on. I'm going to work to get everything over on one side. So I'm going to clean up this a little bit. I just have x plus 5 equals x squared plus 3x plus 2. X squared plus 2x minus 3 equals 0. This will factor. We get x plus 3, x minus 1, which means that x is equal to negative 3, and x is equal to 1. And now because this was a rational function, you want to go back and check for extraneous solutions. Well, something that would make this extraneous if x had been negative 1, or if x had been negative 2, because those would have made the denominator 0. Luckily, we did not get to either of those answers, in which case both of them check out. All right, question 4, dealing with some absolute value. Remember, absolute value, you're talking about distance. So absolute value being distance, I could have run that distance, x, in the positive direction. Oops. In the positive direction. Or I could have run that absolute value, x, in the negative direction. Notice I'm changing every single one of these signs because I'm really taking that whole right side and multiplying it by a negative. Now I just have two different quadratics that I need to solve. So this looks like it's going to be 0 equals x squared minus 3, which means x equals plus or minus the square root of 3. This one, I'm going to add the x squared over to this side, and I'm going to add the x, which becomes 2x. I'm going to subtract the 3. Ooh, this is cool. I just factored this in my last example. X plus 3, x minus 1, x equals negative 3, x equals 1. And now I got to go back and check for extraneous solutions. So if I take the positive square root of 3, that will be equal to 3 plus root 3 minus 3. That one works. So positive root 3 is an answer. If I take the negative root 3, I get 3 minus root 3 minus 3. Cancel, cancel. Ooh, negative root 3 is not equal to the absolute value, so that one fails us. So that's a legit answer. If I plug in negative 3 to my original, I get the absolute value of negative 3 equals 9 minus 3 minus 3, which says that 3 is equal to 3. That one works out for me. If I plug in 1, I get that the absolute value of 1 equals 1 plus 1 minus 3, and that says that 1 is equal to negative 1. Yeet. Not okay. So square root of 3 and negative 3 are going to be your two solutions that work. Moving right along. This one I've got cubes, which means I should be looking for 3 answers. So those 3 answers, if I were to just add the 27, divide by 64, take a cubed root, that will get me my one real answer. But I know that this difference of perfect cubes is going to result in 1 real and 2 imaginary answers. So I'm going to first identify what cubed got me 64x cubed, and that's going to be 4x. Then I'm going to identify what cubed got me 27, and that would be a 3. So those two together, then I got to set up my next sets. So then I'm going to square 4x, which becomes 16x squared. I'm going to square the 3, and then I'm going to multiply these two things together. 4 times 3 is 12x, and this is where the SOAP part comes in. Same sign, opposite sign, always positive sign. So this, great, I get 3/4. There's my one real answer. That one's not so bad. This one is going to result in imaginaries, which means I shouldn't even try to be factoring this thing. I should just jump to the quadratic formula. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. Everybody's favorite song. So x equals negative 12 plus or minus, let's see what we get under this large radical. Our discriminant ends up being negative 432. That's going to have some good squares in it. Over 32. So 432, if I divide that, definitely can take out an I. If I divide that by 9, ooh, we get 48, but that's got some more perfect squares in it. So 432 divided by 36, that's 12. 432 divided by 81, ooh, not going to work. 432 divided by, no, 64, no. 144, there we go. Negative 12 plus or minus I, and then this is now the square root of 144 times 3. And so the square root of 144, which took me a long time to get to, wish I would have gotten there a little faster, becomes 12. And now each one of these has a 4 in it, so negative 3 plus or minus 3i root 3 all over 8 are going to be your two final answers. The answer key was incorrect on the one that was attached to your packet, so make sure that you've noted this correction in your work. All right, next one falls under our category of a radical equation, not only because it's totally cool, but also because it has a square root in it. So to start, I want to isolate the square root. So the square root of x plus 2 is going to be equal to 2x plus 1. The reason I want to isolate that square root is I now want to square both sides. So this becomes x plus 2. This becomes 4x squared plus 4x plus 1, because you actually need to distribute that all out. So now I have a quadratic 4x squared plus 3x minus 1. And the way that you can work from here, you can try to factor this thing, but I don't like factoring when there's a leading coefficient that's a composite number. So I'm going to multiply to negative 4, add to positive 3. So this will become 4x squared. This is going to split into 4x and minus 1x. And then this one will carry down to be minus 1. Factoring by grouping, I'm going to take out a 4x, and I'll be left with x plus 1. I'm going to take out a negative 1, and I'll be left with x plus 1 to make my grouping all work out. So I get 4x minus 1 and x plus 1, which means that x equals 1/4 and x equals negative 1. But then you got to go back and check. So the square root of 2 plus 1/4 would be the square root of 9/4 minus 1. Is that equal to 1/2? Well, that would be 3/2 minus 1 equals 1/2. This one works out. If you plug in negative 1, you end up with the square root of 1 minus 1 equal to negative 2. That seems absurd. Not going to work out. So 1/4 is your final answer. That works. All right, this next one looks really messy. We got some 1/3 powers, which we'll eventually undo by cubing. But you should notice that this 1/3, this is 2/3, which means that really you've just taken this thing and you have squared it. So I'm going to say u is equal to x minus 1 to the 1/3. Now when I go back and write this, I can view this as u squared plus 3u plus 2 is equal to 0. Well, now this isn't so bad. U plus 2, u plus 1 equal to 0. That means u equals negative 2 and u equals negative 1. But I wasn't looking for u, I was looking for x. So I'm going to go back and I'm going to sub in what I know. And I'm going to, now undoing to the 1/3 power, I'm going to raise that whole thing to the 3/1. So this becomes to the 3/1. Those are going to cancel. X minus 1 equals negative 2 cubed is negative 8, which means that x equals negative 7. This one, same thing, raise everything to the 3/1 power to undo that 1/3. So I get x minus 1 equals negative 1, which means that x is equal to 0. And if you go through and you check those answers, you should get that both of those things work out just fine.